All right, boys and girls, this is journal page 364, lesson 15.4, similar solids. Number 1, this says determine whether the solids are similar. Well, for this cone, we can just do two corresponding linear lengths. So we can do, for instance, radius over height of each of these, make sure it forms a proportion. So the radius here would be 5 over its height, which is 12. And we want to see if that's equal to the radius here. Well, it gives us diameter of 6, so we know the radius is 3 over the height of 4. See if that's equal. 12 times 3 is 36. 5 times 4 is 20. That's a big no, because this equals 36 and this equals 20. Number 2, well, these are prisms, so we do have to do surface area of A over the surface area of B equals a linear measure of A over a linear measure of B, the corresponding linear measure of B, squared. So we'll do the surface area of A. The bottom here, 2 times 4 is 8. If the bottom's 8, the top is 8, so that's 16. This is for the surface area of A. 16 for the top and bottom. The right here is 2 times 10, which is 20. The right is 20, the left is 20. 20 and 20 is 40. And the front here is 10 times 4 is 40. The back is 40, so 40 and 40 is 80. 80 plus 40 plus 16 would give us 136. That's the surface area of A. Surface area of B, SOB, equals the bottom here, 3 times 6 is 18. 18 and 18 is 36. The right side, 3 times 15 is 45. 45 and 45 is 90. And the front, 6 times 15 is 90. If the front is 90, the back is 90, that's 180. 80 and 90 is 270, and 36 is 306 for the surface area of B. Okay, so we can set up our proportion now. We have the surface area of A is 136. The surface area of B is 306. Seeing if that is equal to. And we can just use the heights here. Any measure would have worked. We could have used 3 and 2 for the width, 2, 4, and 6 for the length, but I'll use the heights. 10 for the first one, and 15 for the second one. Don't forget, those have to be squared. We know 10 squared is 100, and 15 squared is 225. So my cross products are going to go this way and this way, all the way, corner to corner. 100 times 306 is obviously 306 with 2 zeros, or 30,600. And we're seeing if that is equal to 136 times 225. And 136 times 225, let me think about that for a second. Yes, it's 30,600. So these are equal. So that means yes, these are similar solids. Number 3. Let's kind of sneak back up here. These solids are similar. Find the missing dimensions. Well, since we know they're similar, we can just use their linear measures. And so we have to find the missing dimensions. We have the length is missing and a side is missing on this. We can't find them both at the same time because we can only have one unknown. So we'll use the height of each of them, the height, and we'll do the side. So height over side is what we're going to do. That's an S, not a 5. This would be 4 over that side is 6 equals, this one's height is 3 and its side is unknown. We'll put that S back in there. 6 times 3 is 18. 4 times S is 4, and that's an S. Divide both sides by 4. S equals, 4 goes into 18 4 times with 2 left over, so 2/4 or 1/2. S equals 4.5, what are these, feet? 4.5 feet. Well, that's for the side, but we also had to find the length. So we can use the height and the length this time. Height over length is what we'll be using. Height is still 4. Length this time is 5, that diagonal length right there. Equals, height is still 3, and L for length. This time this equals 15, and this equals 4L. Divide both sides by 4, and L equals, 4 goes into 15 3 times, with 3 left over, or 3.75 feet. So both of the dimensions we had to find for number 3. For number 4, we only have to find one of the dimensions. So this will just be height over radius or radius over height. I'll put height over radius just because I said it first. The height is 1.5. The radius is 3. The height is just h, we don't know yet. The radius is 1. So h times 3 is 3h. 1.5 times 1 is 1.5. Divide both sides by 3. H equals 1.5 divided by 3 is the same as 15 divided by 30, which is just 1/2, or 0.5 centimeters. That's what the height is. Very good. Number 5, the solids are similar. Find the surface area. So for number 5, we'll have to do surface area of one over the surface area of the other equals, and we'll use the length here. It's the only linear dimension they give us. Length over length. Remember, we have to square it. So surface area of the first one is 198 over, we don't know this one, so x. The length of this one is 6. The length of this one is 8. Remember, we have to square those. So this would be 36 and 64. 198 times 64 is 12,672, if memory corrects me. It serves me well when I learned my 198 times tables. And 36 times x equals 36x. Divide by 36, divide by 36. X equals 352 meters. We were finding the surface area. This is meters squared. And number 6. This time, volume over volume equals a linear measure. In this case, it's a side. I don't like using S for side because it looks like a 5. So I'm going to use length, L for a length. Length over length. But remember, this time we have to cube it. So the volume of the first one we don't know this time, but we do know the volume of the second one, 54, equals the length of the first one, 8, over the length of the second one, 3, but we have to cube that. 8 times 8 times 8 is 512. 3 times 3 times 3 is 27. X times 27 is 27x. 512 times 54 is 27,648. Divide by 27, divide by 27. X equals 1,024, and this would be, we're finding volume, millimeters cubed. If you have any questions, please ask tomorrow in class. We have a quiz on Friday, so make sure you have all your questions answered tomorrow, tutoring or in class. We'll see you then.